All right, so on this next test, there is a calculator portion, so we want to make sure we're ready to go with everything the calculator portion entails. Okay, so it says use your calculator. This is stolen from the 18 exam, I think, or at least practice problems. The acceleration of a particle moving along the x-axis is given by that right there, from 0 to 8. At what value is the particle's velocity decreasing most rapidly? All right, so they were mean to you on this question because they said this phrase right here: velocity is decreasing the most rapidly. It's a weird question. Okay, but we're going to be able to put those two things together. So this is a calculator question. They gave me the acceleration, so let's go ahead and type that in. Okay, so I pulled up my calculator. I typed in that equation right there. I want to make sure you're in radians. If you're not in radians in my class, it'll always be wrong. Calculus is always in radians. We're going to change the window. The window on this problem said from 0 until 8. So we're going to go from 0 to 8. And then let's graph that thing. Not too bad. I'm going to change my x or my y minimum here a little bit because it's not big enough. Negative 8. Let's graph that again. There's my graph. What is this a graph of? This is a graph of acceleration. Okay? This is a graph of acceleration. The question is, what value of t is the particle's velocity decreasing most rapidly? Any thoughts on what that means? Andrew, what do you think? So the velocity decreasing means it's net. Why is it going to be negative? Because the slope is negative. Velocity decreasing means acceleration is negative because the slope of velocity, if velocity is decreasing, that's telling me slope. I want acceleration to be negative. Great. So you're looking at that point in the graph and most rapidly. What did you come up with that for that part? Yeah, the most negative number is a great way of saying that. The velocity decreasing most rapidly means the acceleration is at its lowest. This is a graph of acceleration. So all I'm looking for on this graph is the lowest point. It's right there. To find that, I'm going second, calculate the minimum. So we're going to go down to number 3. I move my cursor. That's where I think it happens. So left bound, I move it to the left a little bit, hit enter. I move it to the right a little bit, I hit enter. I hit enter a third time. 1.419 or 1.420 is the answer I'm looking for here. Yes, sir. What are we putting on the paper? Just what we did. Questions? A little strange. Okay, but it's just interpreting what's going on. They wanted to give it to you in a weird way. They could have just said when is velocity slope the least. Well, they asked it a little bit funkier, but that's okay. You got to be able to read through the weeds there a little bit to find the right answer. So again, on Friday or Thursday, your test is going to cover a few things. Okay, it's going to cover being able to look at an equation analytically and find concave up, concave down. So that's doing sign charts. It's going to be graph problems like we did on Friday's quiz. Okay, like those, being able to solve that. And then it's calculator and motion. Those are the 4 things that we have to do well on. Okay, 3 out of the 4 things are on this paper, and these are free response questions from years past. So we should be pretty comfortable with what's on our test once we get done with today. So make sure we are. All right, let's look at 16. So this is from the 2016 exam, question number 2. It's a particular, a particle moves along the x-axis. The velocity is given by this equation right here. The particle is at position 2 when t equals 4. This is not something we need yet. This is a second semester part right there. That would be one of the parts we're not using. We only do part A and B here. That would be something that you would need for part C or D. At t equals 4, is the particle speeding up or slowing down? And then we would go into justify. Even if they didn't say justify here, we would want to justify. You don't want to just pick. Okay, you want to have something to back that up. So to figure that out, let's graph that in our calculator. So pull it up. Y equals. Type in what they just gave me there. So my equation is 1 plus 2 sine x squared over 4. Even if you're just, or x squared over 2. Even if you're just sitting there, you make sure you're typing this in. Don't just stare at the screen. I'm very good at these problems. You are the one that needs the practice, not me. We type that thing in. We're going to mess with, we're just going to graph that thing. Let's graph it. There's my whole graph. The question is, am I speeding up or slowing down at t equals 4? So I'm going to change my window just a little bit so I can have a little less chaos going on. So here is my graph. I want to know at t equals 4, is it speeding up or slowing down? So right there. Thumbs up if you think you're speeding up right there. Thumbs down if you think you're slowing down. We are slowing down right there. But we can't just say that. We need to justify it. Okay? Anytime you're looking at a problem and they ask you for speeding up or slowing down, you want to look at two things. We want to find the velocity at that value, and we want to find the acceleration at that value. How could I find the velocity of that problem given this equation? Plug it in. So there's a couple ways you can do that. You can go calculate the value and plug in 4. That works perfectly well. I always like doing it this way. Alpha F4, Y1, and plugging in the number 4. So I'm going to plug in the number 4. I'm going to hit enter. There's my answer, 2.979. Round to 3 decimals every single time. So I'm going to write that down. You need to write that down. The velocity is this. Then we need to find the acceleration. What could I do in my calculator to find the acceleration? Take the derivative. So we're going to go math 8. I'm going to take the derivative at x is equal to 4. Boom, hit enter. Negative 1.164. Yep, alpha F4. So remember alpha F4. So I got negative 1.164. Based off of those two numbers are what we're going to justify this with. So once we find that, that's great, but now comes the justification. So we're going to say this. The particle at t equals 4, the particle is slowing down. We've done this a couple times now. Anybody remember why we know we're slowing down based off of that? Because what? They have different signs. Because acceleration, I'm sorry, let's go velocity at 4 and acceleration at 4 have different signs. That is what I need there. Okay, that is what you're looking for. Determine if something is speeding up or slowing down, you're looking at velocity and acceleration. If velocity and acceleration have the same sign, you're speeding up. If they have different signs, you're slowing down. That's it. That is what you need to write down every time. There is no wiggle room there. You write down what velocity is, you write down what acceleration is, and then to justify, they either have the same or they have different signs. Yes, ma'am. Yeah, so we found the derivative. So to find acceleration, they gave me velocity. I found the derivative, so I went math 8. And then I plugged in that equation. Remember, that is alpha F4, and we plugged in Y1 right there. Yep. Y1. Remember, we hit alpha and F4. And alpha F4 gives me that secret menu to pick Y1. Cannon? Same sign speeding up, different sign slowing down. Other questions there? Let's go to the second one. Find all the times between 0 and 3 when the particle changes directions, and we are going to justify. So let's hit my window button. They only care about 0 to 3, so I'm going to change my x max to 3 and not anything beyond that. I'm going to hit graph. Show me with your fingers. How many times do I change directions? Michael, when am I going to change, in general, when am I changing directions here? When I cross the x-axis. So I'm going second to calculate. What thing am I going to calculate if I want to know when I cross the x-axis? 0. I'm going to go to 0. I move to the left side. I hit enter. I move to the right side. That's when I think it happens right there. So I'm going to go to the right of it a little bit. I'm going to hit enter a third time. 2.707 is my answer. So I find all the times. T equals 2.707. We always round to 3 decimals. Because, what do you think my justification is? Because what? Velocity changes signs. They gave me velocity, so my justification is in terms of velocity. Velocity changes signs. That's how I know I change directions. Say again? This is motion, yes. Questions here? Let's try it again. So 2011 question. Okay? Pretty similar in what you're asking. Okay? Answer both A and B there. Talk with your neighbor. Spend a couple minutes and figure that out. Go. So we're given velocity. They're asking about the speed of the particle. As soon as you read speed of the particle, okay, especially speed of the particle increasing, decreasing, or speeding up or slowing down, what 2 things do I need to examine? Velocity and acceleration. So as soon as I read that, I'm thinking velocity, acceleration, okay, and especially at 5.5. So to answer this question, I need to know V at 5.5 and A at 5.5. Okay, my pen died. Give me a second. So V at 5.5 and A at 5.5. So to do that in my calculator, what do I need to do in my calculator to find the velocity at 5.5? Plug it in. Okay, so there's a couple different ways you could do that. I'm going to do it the way I like the best, which is alpha F1. I already graphed it, sorry. I already typed it in. I'm going to go alpha F4, Y1. I'm going to plug in the number 5.5. Boom, there's my answer, negative 0.453. So velocity at 5.5 is negative 0.453. Great. The second one I need to know is acceleration. How do I find acceleration in my calculator? Take the derivative. I'm going math 8 dx of alpha f4 y1. Take the derivative of that equation again at 5.5. Type it in, hit enter. I got negative 1.359. You have to write down both of these things. You need to say velocity is equal to something, acceleration is equal to something. Then we're trying to describe speeding up or slowing down. Thumbs up if you think you're speeding up. Thumbs down if you're slowing down. We are speeding up. Okay? So my answer is speeding up at t equals 5.5 because, yeah, I've not gotten a new one yet. I borrowed this one from somebody. It is speeding up at that time because why, Luke? What can we say? Have the same sign. Great. That's what we're looking for. Speeding up, slowing down, we're looking at velocity, acceleration. If they are the same sign like this one, we are speeding up. Great. Next one says between 0 and 6, the particle changes directions exactly once. Find the acceleration at this time. Okay, so we're doing the same thing. We're looking at our calculator. We're going window 0 to 6. I want to find the acceleration the one time the velocity changes signs. Yes, sir. Don't do that. Your answer. So the question was, can I say that I was moving away from the x-axis? No. You have to talk about velocity and acceleration, and are they the same sign or not? That is your only justification you can give. Okay. Nope. Because that, yeah, it kept coming, but that was different too. Okay, thank you. Yep. So the particle changes directions exactly once. Tell me now when I change directions. There. When velocity changes signs, I change directions. So to figure out what my acceleration is, I need to know that value. So I'm going to go second, calculate. What am I going to calculate? The 0. So go to 0. It's happening right about there. So I'm going to hit enter right there. I'm going to go to this side, hit enter right there, hit enter a third time. Boom, there's my answer, 5.1955223. What you can't do is you cannot round that. You're not allowed to, okay? We can write down that number. When did I change directions? At t equals 5.195. I hate writing down numbers. 1955223. You can't round because it's not the final answer to this question. The final answer is what's the acceleration? We're not allowed to round it until the very end. So what do I need to do now to find the acceleration at that time? Plug it into the derivative. Now here's one thing you can do. Once I've typed that in, okay, I just found it. I'm going to hit second quit. I'm going to go back to my regular screen. Hit the X button and hit enter. That's the number I want, that 5.199 number. Okay, it didn't round it. So what you can do there as well is you could go take that X value, and I'm going to store it. This button right here, store. I'm going to store it as alpha A. So now every time I hit A, it gets me that number until I save over top of it. That way I don't have to type it in again. If you want to type it in again, great. Write down the whole decimal and go. Okay, once I've done that, then I'm going math 8. I'm finding the derivative because I'm looking for acceleration of this function at x is equal to that number right there. Boom, hit enter, negative 1.587. So the acceleration at 5.196 was negative 1.587. Now I can round because that is my final answer. Makes sense what we did. We found the place where it changed directions, and then we plugged that number into the derivative. Okay, again, you cannot round it. Questions there on the front side? Calculator with motion. We got to be good at both of those things. On the back side, this is like your quiz on Friday. They gave you a graph. They're asking you to justify some stuff. Work with your neighbor. Answer both parts on the 2012 question. Go. So, points of inflection. The first thing you always want to do is look at what did they give you. They gave me a graph of G prime. I like as I walked around, a lot of you had it written again. It is G prime. Points of inflection. Show me with your fingers. How many points of inflection do you have here? Points of inflection. There should be 2. Taylor, when did you have points of inflection here? 1 and 4. Point of inflection at 1 and 4 because why? G prime has a relative extrema. That is the best answer to give here. And you have to say G prime. If you didn't say G prime, it is wrong. G prime is what they gave me, so that's what my justification is. She could have said G prime slope change signs, or G prime change from increasing to decreasing, or decreasing to increasing. Say relative extrema. It's the easiest way to do it. Great. There's part A. Part C says find the maxes and mins, and then justify your answer. Okay, so maxes and mins. Show me the fingers. How many and the one thing we got to pay attention to is this. That is an open interval. It doesn't include -3 or 7. It's not underlined. So neither one of these answers am I going to say -3 or 7 because it's not included in there. Okay, and they'll make sure you clear that up. Jesse, when did you think we have a maximum here? At 2. Why did you think x equals 2 is a maximum? G prime changes from positive to negative. Good. That's our justification. We're looking for minimums. If we're saying minimums here, Jalen, when do you think we have minimums? -1 and 6. Why at -1 and 6? No, I don't like that. You said because, don't say because it changes, because G prime changes from negative to positive. It seems so silly, and at times I agree with you, but know that on the AP exam, for you to earn college credit, you cannot say it. You have to say G prime, so make sure you're doing that. Questions with anything here? The one below it, pretty similar for the first two. Try letter C really quick with your neighbor. Letter C, you're trying to find f double prime at -5 and f double prime at 3 based on that graph. Do that for me. Here we go. We're focused on part C. For each of f double prime at -5 and f of 3, we're trying to find the value. This is a graph of f prime. If I want to look at f double prime, what do I need to do with this graph? Look at what? The slope. Show me with your fingers. What do you think the slope is here at, what are we doing at -5? So right here. What do you think the slope is right there at -5? Show me with your fingers. It should be -1/2. Should be my answer. -1/2. Because I'm looking at the slope. It's this value. You've got a line here. Every point on that line has the same slope. So pick two ordered pairs. 6, -2 is an ordered pair, and -2, 0. You could just count. Okay, I went down 1, 2. I went over 1, 2, 3, 4. So it's -2 over 4. It's -1/2. Okay, or you could do y sub 2 minus y sub 1 over x sub 2 minus x sub 1 and get -2 over 4, which gets me -1/2. I don't care how you get it, but you should get -1/2 there. You don't have to give a justification. That's your answer. F double prime at 3. There's 3. What is the slope going to be at 3? Undefined. F double prime at 3 does not exist. Undefined. Does not exist because f prime at 3 has a corner point. That's it. Don't make it more difficult than that. Those are the free response questions you want to be ready for this week. Okay? Understanding motion and using your calculator, but also being able to look at the graphs just like we took the quiz on Friday. Test is on Thursday.